Hello, I'm Dane, and this is Dane Explains. I've already done videos on possible different biochemistries for life, specifically one on life that uses ammonia instead of water, and another one that uses methane instead of water. The thing both those videos have in common is they examine what would happen if you replace water. Well, most of you probably already know when people think about alternative biochemistries, water isn't the most popular chemical to sub for. The most popular one is carbon, specifically replacing it with silicon, which reacts a lot like carbon, but is one level down on the periodic table. Well, is silicon life even possible? What would it even look like? Let me explain. In many sci-fi movies, one of the popular throwaway lines when Earthlings meet a new alien species is that they are silicon-based life forms. A lot of writers just throw that in there like the sci-fi movie scripts are a meatloaf, and silicon-based life biochemistry is cilantro. The only thing that cilantro belongs in is the trash. But what about silicon-based life? And no, artificial intelligence doesn't count here. Their brains might be made out of silicon wafers, but that doesn't make them silicon-based life. Silicon-based life forms are so common in sci-fi because silicon is very similar to one of the most important elements in our biochemistry, which is carbon. Carbon is like the bones of the molecular world. On a molecular level, life uses it as the most basic building block that everything gets attached to, since it's able to create 4 very stable bonds at the same time. Silicon is found down one row in the periodic table, and if you remember your high school chemistry, elements which are in the same column in the periodic table generally have similar properties, because they can usually sustain the same number and type of bonds with other atoms. So, as you can see here, if any element is going to be replacing carbon, silicon is going to be that element. Silicon, since it has a larger atomic number, is of course heavier than carbon. But there is another bigger caveat, and that's a larger size of the atom. The larger size means the atom's electrons are not bound as tightly, and also when bound up in a molecule, the silicon atoms can't get as close together as carbon atoms do. This causes silicon atoms to form less stable bonds than carbon atoms, which means it reacts with other elements more easily. So, you'd think this would allow life forms that use silicon instead of carbon to have an easier time due to the lower energy thresholds for reactions that take place. Also, silicon is extremely common. In fact, silicon is the second most abundant element in Earth's crust, just after oxygen. Carbon isn't even at the top 10. Considering those facts, it seems obvious why sci-fi movies turn to it so much for alien biochemistries. So, if there's so much more silicon than carbon, and silicon reacts more easily than carbon, why isn't Earth life silicon-based instead of carbon-based? Well, it's hidden in the fact that silicon is the second most abundant element after oxygen. Normally when you think of oxygen, you think of the diatomic gas that we need to breathe to survive. In a rather complex process I'm going to skip over because my video isn't a college class on the biochemistry of respiration, chemotrophic life like ours uses diatomic oxygen to dump low-energy electrons, which reacts with carbon atoms, creating the gas of global warming fame, carbon dioxide. So, silicon can't do that, right? Well, not so fast. Silicon dioxide exists and is extremely abundant, hence why there's so much silicon and oxygen in Earth's crust. Therein lies the problem. Silicon dioxide forms the crystalline solid at room temperature that we know as sand. Yep, sand. Due to the heavier atoms and the weaker bonds, the oxygen atoms, which like to make 2 bonds at once, like to bind 2 silicon atoms in a structure like this. Due to the lighter atoms and tighter bonding of oxygen to carbon, both the oxygen bonds and carbon dioxide get bound to the same carbon atom, creating a molecule that has 1 carbon for its body and 2 oxygen atoms for its wings. Counterintuitively, this makes silicon harder for biological mechanisms to use, since most of it's bound up in a crystal lattice rather than free-floating, able to be easily absorbed. So yeah, that's why Earth life doesn't use silicon. But are there circumstances that life might use silicon instead of carbon? Well, silicon dioxide can be a gas, but it's kind of a catch-22, because it doesn't become a gas until it reaches over 5,000 degrees Fahrenheit, or almost 3,000 degrees Celsius. That's way outside the temperature of any form of life that we can think of. Even if the life used a polar ionic compound like a salt as a stand-in for water, The temperature is still way too high because even salts are only molten up to around 3000 degrees Fahrenheit, or less than 2000 degrees Celsius. So only off by a couple thousand degrees or so. The reason why you'd pick a polar liquid is because polar liquids dissolve other compounds more easily, making them more useful solvents for biochemical processes. Although the silicon dioxide doesn't need to be a gas to be utilized by biochemical mechanisms, right? It can be a liquid and does have a liquid range that overlaps with some molten salts. The one issue with that is that molten salt and molten sand are like oil and water, since silicon dioxide is nonpolar. Considering silicon's tendency to bind itself up in inert sand and how hard it is to get enough heat energy into the sand to make the silicon accessible to biological mechanisms, it would seem that silicon-based life, as is depicted in the movies, would be completely out of the question. However, if you work in the glass industry, you've probably noticed I'm barking up the wrong tree with this issue. That's because there's another chemical that can dissolve sand, and it can do it at temperatures even lower than room temperature. That chemical is hydrofluoric acid, which ironically is a topic people have already requested that I cover, because hydrofluoric acid is also a candidate solvent for replacing water in alien biochemistries. But that's a story for another video. Thank you for watching. If you like this video, please press the like button. Subscribe to my channel and ding the bell to get notified when I post new videos. Also, please support me on Patreon, link in the description. The more people support me, the more time I can dedicate to making videos like this one. So, until next time, have a great week.